Now we'll solve some problems related for the rate of chemical reactions. Okay, how we can solve this problem? The first order, in the first order reaction, what is the rate constant? He asked you about the K. K, it will be the rate constant for reaction. If the rate is 0.05 molarity per second, so here you have the rate of reaction. And the reactant concentration 0.03 molarity. So here the A equals to 0.03 molarity. Okay. The first step you should write, okay, you should write the given. What is the given here? The given, it would be rate equals to 0.05 molarity per second, and the concentration A equals to 0.03 molarity. He asks you about the K unknown, the rate constant. So what is the equation that you would use? The equation here, it will be rate equals to rate constant multiplied by the concentration. Okay, so here this for the first order reaction. You want to calculate K, so K equals to rate divided the concentration A. Rate here equal to 0.05 molarity per second. And here the concentration equals 0.03 molarity. Okay, cancel molarity with molarity. You will divide this number 0.05 by 0.03 equals to 1.66. Okay, you round this number to become 1.7. Okay, what is the remaining unit here? It would be divided by second, so it would be second minus 1. So now we finished the first problem. The second problem. What is the rate of the first order reaction? So here also the same idea. You would use the first order rate reaction here to calculate here the rate of reaction. The second problem, what is the rate of the first order that has the reactant concentration 1.1, so you have here A concentration, and the rate constant K equal 0.014 per second. So he asked you here about the rate. So the first step, you write the given. The given A equals to 1.1 molarity, and the constant equal 0.14 per second, or second minus 1. He asked you about the rate. The rate, it will be unknown. So how we can solve it? The first step, yes, you will write the equation. Rate equals to the constant multiplied by the concentration. Here, the constant, it will be 0.14, okay, per second, multiplied by 1.1 molarity. The final answer here, it will be 0.154, and the unit here, it will be molarity per second. So here is the answer for the second problem. The third problem here, he asks you about what is the reactant concentration. So he asks you about A. Okay, so the A, it will be unknown. If the reactant constant K equal to 0.2 per second and the rate equal to 0.004 molarity per second, so here it will be rate. The first step, you write the given. The given, it will be K equal to 0.2 per second, and the rate equals to 0.004 molarity per second, and he will ask you about the concentration of reactant. After that, you will write the equation. Rate equals to the constant multiplied by concentration. So here you want to calculate the concentration. So the concentration A equals to rate divided K as a constant. So rate here 0.004 molarity per second divided by the constant here 0.2 per second. So here the answer, it will be 0.02, 0.02 molarity. Why? Because here the unit you can see second with second, the final remaining unit molarity. Okay, now we finish the third problem. Problem number 4. What is the rate? He asks you here about the rate. What is the rate of the first order? So you know the equation for the first order that has the reactant concentration. You have here the reactant concentration. A here 0.1 molarity, and the rate constant here K equals 0.1 per second. After that you write the given. The given concentration equal to 0.1 molarity and the constant equal 0.1 per second, and he asks you about the rate unknown. After that you write the equation. The equation here, rate equals to constant multiplied by the concentration. This only, okay, you should remember this point, only for the first order. So rate here equal the constant K 0.1 per second multiplied by the concentration 0.1 molarity. The final answer here, it would be 0.01 and the unit molarity, yes, per second. This is the answer for the problem number 4. Problem number 5. In the first order, we still in the problem of the first order. What is the reactant concentration? He asks about A. So A unknown. If the rate constant K equals 0.1 per second and the rate equals 0.00 molarity per second. So here this the rate. After that you write the given. The given here, it would be K equals 0.1 per second, or you can write as a second minus 1. Rate equals to 0.001 molarity per second. After that, the concentration, yes, unknown. After that, you write the equation. The equation, yes, rate, okay, here for the first order. So rate equals to constant multiplied by the concentration. So concentration here equals to rate divided by the constant. So rate here 0.001 molarity per second, and the constant here 0.1 per second. After that you will cancel second with second. You will divide it 0.001 by 0.1 equals to 0.01. Here, yes, the unit, it would be molarity for concentration. After that, the last problem, before the last problem, problem number 6. If the first order reaction, what is the rate constant? Here asks you about the constant as a K. If the rate, this rate, equals 0.01 molarity per second, and the reactant concentration A here equals to 0.01 molarity. You write the given. Rate equals to 0.01 molarity per second, and the concentration equals to 0.01 molarity. He asks you about the constant K. Okay, you write the equation. Rate equals to K multiplied by the concentration. Here he asks you about the K. So K equals to rate divided by the concentration. Here the rate equals to 0.01 molarity per second, and the concentration 0.01 molarity. Okay, cancel molarity with molarity. The final answer here of this problem, you will divide it 0.01 by 0.01. Yes, it will be 1 second minus 1 or 1 per second. Okay, or 1 second minus 1. Okay, so here is the answer for this problem. The last problem now. Okay, here one of the problem called higher order action. For this problem, he asks you about the order for this reaction. How we can calculate the order for this reaction. Firstly, you will observe here the initial concentration of A and the initial concentration of B. You have here 0.05 becomes 0.1 becomes 0.2. After that, it will be constant here. Here, for the initial concentration of B, it started by 0.05, 0.05, 0.05. After that, it will be 0.05. It will be increases here. So, how you can determine the order? You determine the order across the change. So, like here at this step, okay? For this step, at the first or the second, as you like, I'll choose this one, okay? And I'll choose this one. Okay, the first step you write the equation. The equation here, it will be rate equals to the constant for the reaction equal to the concentration A raised to the power x and multiplied by the concentration B raised to the power y. So the first step you will calculate x, after that you will calculate y, add them, you can get the order for the reaction. So let's start here by A. I will start by A here. You have 0.1, it will be divided by 0.05. Here, like the concentration, okay? The concentration here, it will be 0.1 and 0.05. I will divide it here. These numbers, 0.1 divided by 0.05. All of them raised to the power x. Okay, after that here, what is the rate? The rate here, it will be 4 multiplied 10 power negative 3 divided by 2 multiplied 10 power negative 3. Cancel 10 power negative 3. 10 power negative 3. Here 4 divided 2 equals 2. And here 0.1 divided 0.05 equals 2. So here you have 2 power x equals 2. Okay, mathematically, so the x equal 1. X equal 1. So now we solve the first one here. The x here equals 1. Let's complete the second one. We want to calculate y. How you can calculate y? From the concentration of y. You will divide it 0.1 divided 0.05. Let's start by this one. 0.1 divided by 0.05. All of them raised to the power y equal. The concentration here that's related for it. Okay, here is concentrated. Sorry, this the rate. You will divide it 3.2 multiplied 10 power negative 3 divided by 0.4 multiplied by 10 power negative 3. Cancel 10 power negative 3, 10 power negative 3, so it will be equal to 8. Okay, after that, 0.1 divided 0.05 equals to 2. Okay, it would be power y equals 8. Mathematically, what is the number you put here? Okay, replace of y to come 8, it will be 3. Okay, so y here equal 3. So I'll put y here equal 3. After that, I would add these two powers to determine the order. So 3 plus 1 equal to 4. So what is the order of this reaction? This it would be the order of reaction. Okay, thank you for listening and I hope to see you next time.